Look around the room you are in. The walls, the floor, the soft edges of the light. It all feels solid, settled, undeniably there. And you have never once doubted that it stays exactly as it is the moment you stop looking at it. But a little over a century ago, physics found something in the fine print of reality that it has never been able to explain away. At the smallest scale, a particle does not seem to have a definite position at all, not until something measures it. Watch which path it takes, and it behaves one way. Look away, and it behaves another. Down there, at the bottom of everything, reality seems to hold its breath until it is checked. And that opens a question so old it was carved into temple walls, now returning through the back door of physics. The universe is 13.8 billion years old, and for almost all of that time, there was no one here to look. So who, or what, has been watching? Before we drift in tonight, if questioning reality this slowly is how you like to fall asleep, a quiet like or subscribe genuinely helps this channel grow. It is a small thing for you, but it means the world to me. Now, let's begin. Part 1. The question physics thought it had buried. There is a question so old that people carved it into the walls of temples long before anyone knew how to write down an equation. And there is a science so new that it can predict the behavior of a single atom to 12 decimal places, which is a little like measuring the distance from one coast of a continent to the other and being wrong by less than the width of a human hair. For almost all of human history, those two things, the ancient question and the exact science, had nothing whatsoever to say to each other. They lived in separate rooms. One belonged to priests and philosophers, the other to people in white coats with careful instruments. And then, a little over 100 years ago, physics walked into the wrong room by accident and asked the old question out loud, and it has never fully found its way back out. The thing physics stumbled into was not a new particle. It was not a new force. It was something far quieter and far more unsettling than either of those. It was a crack, a hairline fracture running straight through the picture of reality that science had spent centuries carefully assembling. For hundreds of years, physics had painted a very reassuring picture. It described a universe that simply existed, all on its own, whether or not anyone was there to witness it. Stars ignited in silence, galaxies wheeled and collided in the dark, atoms joined together and broke apart without a single pair of eyes anywhere nearby. The universe in this picture was a great machine that ran perfectly well in an empty room, and our arrival was a late and unimportant detail. The machine did not need an audience, and there was something deeply comforting about that picture, even in its indifference. It meant the world was solid. It meant that when you left a room, the room stayed. It meant that the moon hung in the sky whether or not anyone glanced up at it, that a falling tree in an empty forest still crashed to the ground, that reality had a spine of its own that did not depend on you in the slightest. This is the intuition nearly everyone carries, whether or not they have ever put it into words. The world is out there. It is definite. It has properties, a location, a state, a way that it simply is, at every moment, entirely independent of whether anyone is checking. Your looking reveals the world. Your looking does not make it. That is the bedrock assumption underneath ordinary life, underneath common sense, underneath most of the history of science itself. And it is exactly this assumption, so obvious that for most of human history no one even thought to question it, that quantum physics walked up to, tapped on the shoulder, and asked, very quietly, "Are you completely sure?" Then physicists built better instruments and looked closer. They looked past the surfaces of things, past the molecules, past the atoms, all the way down to the smallest level they could reach. And down there, in the quantum world, the reassuring picture came apart in their hands. Down there, matter does not behave like a collection of tiny, definite things that already have properties whether you check them or not. Down there, matter behaves as though it is holding its breath. It refuses to commit. It exists as a kind of whisper, a spread of possibilities, a haze of maybe, until something happens that we have learned to call a measurement. And in the instant of that measurement, the haze seems to gather itself up and choose. Out of all the things it could have been, it becomes one definite thing. The universe, at its smallest scale, appears to make a decision, and it appears to make that decision only when it is checked. For an entire century, the finest minds who ever practiced physics have argued about what that means, and they have not reached agreement. This is worth saying slowly, because it is easy to assume that a science this precise must have settled such a basic point. It has not. Even now, there is no single interpretation of quantum mechanics that every physicist accepts. The very people who built the theory, the people whose names are on the equations you would find in any textbook, could not agree on what they had actually discovered. Some of them insisted there was nothing mysterious happening at all, that the whole thing was a misunderstanding dressed up as a paradox. Others, in their quieter moments, in letters and late-night conversations, wondered whether they had brushed up against the deepest secret in all of existence. Because here is where the old question comes creeping back in. If reality only becomes definite when it is measured, then a strange and childlike question follows, one that will not go away, no matter how sophisticated you are. Who, or what, has been measuring the universe? The cosmos is thought to be about 13.8 billion years old. For almost all of that unimaginable stretch of time, there was no one here. There was no eye to open, no mind to notice, no instrument to record. So before the first eye ever opened, before the first living cell ever divided, before the very first star ever caught fire in the dark, was anything there at all, in any definite sense? Or was the whole universe still holding its breath, waiting? Tonight, we are going to follow that question as far as it can honestly be followed. We will go down into the laboratory to see the gentle little experiment that started all of this. We will sit with the disagreement among the physicists and understand why they scattered instead of converging. We will follow one tempting idea to the very edge, the idea that a conscious mind might be the thing that makes reality real, and we will watch that idea collapse under its own weight. Then we will rewind the entire universe back to its first moment and count, at every step, how many eyes were open to see it. We will visit the strange fact that people separated by oceans and centuries kept arriving at the same answer to this question, by roads that never crossed. And finally, we will reach the edge of an idea that science can neither confirm, nor deny, nor quite escape. An idea that was whispered in temples and cathedrals for thousands of years, and that has now come drifting back in through the back door of physics. I want to be honest with you before we take a single step further, because honesty is the whole point of a journey like this one. Some of what we explore tonight is solid, confirmed physics, tested to that absurd 12-decimal precision. Some of it is careful speculation that serious scientists take seriously, and some of it lies entirely outside the reach of any experiment that could ever be built, in the country of philosophy and theology, where the question came from in the first place. I will tell you, at every stage, which is which. I will never dress a guess up as a fact, and I will never pretend the equations say something they do not say. What I can promise is that the question itself is real, that physics really did blunder into it, and that once you see it clearly, it becomes very, very hard to stop thinking about. So settle in. We are going to start with the single most quietly disturbing thing ever seen in a laboratory. Not an explosion, not a collision, something gentle, something that, at first glance, looks like nothing at all. Part 2. The Wave of Possibilities. Picture a wall with two thin, parallel slits cut into it, two narrow openings side by side. Now send waves toward that wall. It does not matter much what kind of waves you imagine. Water waves in a shallow tank will do nicely. The waves reach the wall, and a portion of each wave passes through each of the two openings. On the far side, you now have two sets of ripples spreading out and overlapping, And where they overlap, something very simple and very beautiful happens. In places where the crest of one wave meets the crest of the other, they add together and make a taller crest. In places where the crest of one meets the trough of the other, they cancel each other out and flatten to nothing. If you put a screen on the far side to catch the result, you see a row of alternating bands. Bright, dark, marching across the surface. Physicists call this an interference pattern, and it is the unmistakable fingerprint of a wave. Water makes it, sound makes it, and light, we learned a long time ago, makes it too. We learned that about light at the very dawn of the 19th century, when a physician and all-around brilliant mind named Thomas Young sent a beam of light through a pair of narrow openings around the year 1801 and watched those same bright and dark bands appear on the far wall. It was a small experiment with an enormous consequence. It settled a long argument by showing that light travels as a wave, and for more than 100 years afterward, the world felt tidy and well sorted. Light was a wave. Matter was made of little solid particles, tiny pieces of stuff, like impossibly small billiard balls. And those two categories, waves and particles, were as separate as fire and stone. This was the physics of the 1800s, and it was calm, ordered, and confident. It was a universe of ripples and pellets, each obeying laws you felt you could almost hold in your hand. Nothing about it hinted at what was coming. The strangeness only begins when you make the experiment smaller, much smaller. Instead of a continuous beam of light, imagine you could fire it one tiny piece at a time. One single particle of light, then a pause, then another, then another. And we can do this now, not only with light, but with electrons, the very particles that swarm in the outer shells of every atom in your body. We can release them one at a time, so slowly that only a single electron is ever crossing the apparatus at any given moment. Think about what that means. There is nothing else in there. There is no second electron for it to bump into, no other wave for it to interfere with. Each one travels the whole way completely alone. And when a single electron reaches the screen, it does exactly what you would expect a tiny solid thing to do. It strikes one spot and leaves a single, tiny dot. One particle, one point of impact. Perfectly sensible. But now let the experiment run. Let 1 become 100, and 100 become 1,000, and 1,000 become 1,000,000. Each electron arrives alone. Each one lands at a spot that seems, on its own, entirely random. And then, slowly, out of that storm of individual dots, something rises up that should not be there. Bright bands, dark bands. The interference pattern returns. The very same fingerprint of a wave, built up one lonely particle at a time. Let me put you in the room while it happens, because the wrongness of it only lands if you watch it slowly. You are standing beside the screen in a darkened laboratory. The apparatus hums faintly. Every so often, a single electron is released, and after its silent crossing, one small point of light appears on the screen in front of you. There it is. Then, a moment later, another, somewhere else entirely, seemingly at random. Then another. It is almost boring. Tick, a dot. Tick, another dot. Over here. Tick, tick, a dot up in the corner. A dot near the middle. Each one arrived completely alone, with the entire apparatus empty around it. Nothing for it to touch, nothing for it to interfere with. Each one is just a particle, a tiny speck, landing where a tiny speck should land. You could watch 100 of them and see nothing but a scatter of unrelated points. But you do not stop at 100. You let it run. And as the dots accumulate, minute after minute, hour after hour, your eye begins to catch something that your mind does not want to accept. The scatter is not a scatter. The dots are avoiding certain stripes on the screen entirely and crowding into others, as though each lonely particle somehow knew, before it landed, where all the others had gone and where they would go next. Slowly, Out of thousands of independent, unrelated arrivals, the bright and dark bands assemble themselves, with no conductor, no coordination, no communication between the particles that could ever be found. Every one of them traveled alone, and yet, together, they have drawn the unmistakable signature of a wave passing through both slits and interfering with itself. The pattern was never in any single electron. It was in the odds each one obeyed, and the odds behaved as though every particle, on its solitary journey, had quietly explored both paths at once. I want you to sit with how strange this is, because when results like these first began to appear, physicists did not celebrate. They recoiled. Many of them were convinced that something had gone wrong with the equipment, that a stray vibration or a flaw in the apparatus was manufacturing a pattern out of pure noise. It had to be a mistake. Particles were particles. The idea that a single, indivisible speck of matter could somehow spread out and interfere with itself was not just surprising. It seemed to violate common sense at the deepest level, and yet the checking only made it worse. The result refused to go away. They tested it again and again, for decades, with ever more care and ever stranger materials. Electrons made the pattern, then single photons, lonely packets of light, fired one at a time, made it too. Then whole atoms, thousands of times heavier. And then, most astonishing of all, large molecules, intricate clusters made of hundreds and eventually thousands of atoms, objects almost on the edge of what a microscope can see. Each of them, sent through the apparatus alone, built up the very same bands. The effect was not a quirk of the electron, it was a property of matter itself. So think carefully about what each of those objects seems to be doing. Each one travels by itself, with nothing else around to interfere with, and yet collectively they arrange themselves as though every single one had somehow passed through both slits at once and interfered with itself on the way across. A lone particle, behaving like a spread-out wave, as if, on its journey, it stopped being a definite object sitting in one definite place and became instead a range of possibilities, quietly exploring every path at the same time. This is what physicists mean when they say that matter is described by a wave. Not a wave in water or in air, but a wave of probability. Before it lands, the electron does not have one position. It has a whole spread of potential positions, each with its own likelihood, all of them coexisting at once. The mathematics that captures this haze of possibility is called the wave function, and it forced physics to give up something it had never even thought to question. It forced physics to give up the certainty that every object, at every single moment, simply has a location. In the old picture, if you knew enough about a thing, you could say exactly where it was and exactly where it would go next. The wave function shattered that promise. It does not tell you where a single electron will land. It refuses to. It offers you only the odds, only the probability of finding it here rather than there. And here is the part that should stop you cold, because it is the reason no one can simply dismiss all of this as a bit of mathematical fog. Those odds are perfect. For the better part of a century, the wave function has been the single most successful predictive tool that human beings have ever built. It has been tested to a precision so extreme that it beggars comparison. Every transistor, in every computer, every laser, every medical scanner, every glowing screen you have ever touched, all of it runs on the accuracy of this description. Nothing in the entire history of science has been confirmed more thoroughly. The theory works. It works flawlessly. It simply, stubbornly, refuses to tell us what it means. Let me try to make the strangeness land in the room where you are sitting. The chair beneath you feels solid. The floor feels solid. Your own hands, if you look at them, feel about as definite and real as anything could possibly be. But at the deepest level physics can reach, none of that solidity is a settled fact sitting there on its own. It is a wave of possibilities that has simply been touched and jostled by the world, so relentlessly, so many trillions of times, that it has been forced to look solid. The definiteness you feel is not the bottom layer of reality. It is something that happens to the bottom layer. And it seems to happen, most sharply and most mysteriously, in the exact moment that something checks, which raises the obvious next question, the one that broke the calm forever. What, precisely, counts as checking? What happens if we simply try to catch the electron in the act and watch which slit it actually goes through? Part 3. The doorway that changes when you ask. It sounds like the most reasonable request in the world. We have a particle that behaves like a spread-out wave when we are not watching, and we would simply like to know which of the two slits it really passes through. So we set up a small detector at the openings, a little instrument that quietly registers the electron as it goes by. We change nothing else about the experiment. We do not block a slit. We do not push the particle. We only watch the doorway, and the interference pattern vanishes. The bright and dark bands, the fingerprint of the wave, collapse into two plain clusters, one sitting behind each slit. Exactly what you would expect from ordinary little pellets fired through two holes in a wall. The wave behavior is simply gone. The moment we obtain the information about which path the electron took, it stops being a wave of possibilities and commits to being a particle with a single, definite history. And here is the detail that turns a curiosity into a genuine mystery. If you switch the detector off, the interference pattern comes back. Switch it on, and the pattern dies. Off, and it returns. On, and it dies again. The universe seems to behave one way when the question is asked, and a different way when it is not. Stand at the apparatus again, and watch this one directly, because it is even stranger than the build-up. The interference bands are glowing softly on the screen, that familiar ladder of light and dark, the fingerprint of the wave. Now, without touching the beam, without changing anything about the particles or the slits, you reach over and switch on a small detector at the openings, a quiet little instrument whose only job is to notice which slit each electron passes through. And as you watch, the bands smear. The ladder of light and dark dissolves, softening and collapsing, until all that remains are two dull, ordinary stripes, one behind each slit, exactly what you would see if you were firing tiny pellets through two holes. You reach over and switch the detector off. The bands come back, sharp and clean. On, they die. Off, they return. On, gone again. Nothing about the particles has changed. The only thing you have altered is whether the world, somewhere, holds a record of which way each one went. And that alone, the mere existence of the information, is enough to change how reality behaves. It is hard to describe how unsettling this is the first time you truly grasp it. It feels less like an experiment and more like catching the universe glancing over its shoulder to check whether it is being asked, before it decides what kind of thing to be. I want to slow down here, because this is the exact point at which language becomes dangerous, and where almost every popular retelling of this story goes wrong. When a physicist says the word observation, they do not mean a person paying attention. They do not mean consciousness, or awareness, or a curious mind leaning in. They mean an interaction. They mean a measurement, in the coldest and most mechanical sense of that word. Any physical process in which the quantum system becomes entangled with something larger that ends up carrying a record of what happened. A detector, a stray photon bouncing off, a single molecule of air brushing past. The electron does not respond to being seen. It responds to being touched by the world in a way that leaves behind a trace of where it was. You can prove this to yourself, in a sense, by imagining the cruelest possible version of the experiment. Take the detector at the slits and seal it inside a dark box, with no scientist anywhere near it, no one reading its output, no living thing aware of what it records. That sealed, unwatched machine will erase the interference pattern just as completely and just as reliably as a scientist standing at the screen and staring. The particle does not care whether anyone knows. It only cares whether the world, somewhere, has taken note. And that should have settled the whole matter. It should have made the entire thing ordinary and mechanical and free of any whiff of mysticism. But it did precisely the opposite, because it left physics holding a question that it has never, in 100 years, been able to answer. And that question has a name. It is called the measurement problem. Here is the problem, stated as plainly as I can manage. What, exactly, counts as a measurement? At what precise point does a foggy cloud of possibilities become a single, solid fact? When the wave function is left alone, it evolves smoothly and predictably, spreading and flowing like the wave that it is. And nothing in that smooth, elegant evolution ever forces it to pick just one outcome. The mathematics that describes the spreading cloud is beautiful, and it never once collapses on its own. And yet, the very instant we measure, one outcome is exactly what we get. The equations describe the cloud perfectly. They describe the final result perfectly. And they say almost nothing about the transition between the two, the instant the many becomes one. That gap, small enough to write out in a single line of mathematics, has never been closed, not in 100 years of trying. To feel the full weight of the puzzle, follow the logic one careful step further, because this is where it becomes genuinely dizzying. A detector is not a magic object. It is not some special device that stands outside the laws of physics. It is itself made of atoms, trillions upon trillions of them, and every one of those atoms is governed by exactly the same quantum rules as the electron it is trying to catch. So, by the theory's own logic, the detector should not collapse anything at all. When it interacts with the electron in its haze of possibility, it should simply join that haze. It should become a slightly larger cloud of maybe, a state in which this happened and that happened are both still true at once. And now, when your eye looks at the detector's readout, your eye is also made of atoms, so your eye should join the cloud as well. The signal travels up your optic nerve, which is also made of atoms, into your brain, which is also made of atoms. At every single stage, the fog should only grow larger, swallowing each new system into the haze rather than resolving it into one answer. This chain of reasoning has a name. It is called the von Neumann chain, after the mathematician John von Neumann, who spelled it out with brutal clarity in his great work on the foundations of the theory, published in 1932. And what von Neumann showed is deeply unsettling. The mathematics never tells you where the chain ends. You can place the dividing line, the cut between the quantum haze and the single definite fact, almost anywhere you like along that chain, and the predictions come out exactly the same. You can put the cut at the detector, or at the eye, or at the brain, and the equations do not object. The theory is completely silent about the one thing we most desperately want to know. Where does the blur become a world? Where, in that long chain, does a shimmer of possibility finally harden into the single reality you are actually living inside? There is one link in the chain that von Neumann noticed never seems to fall into the fog, and we will return to it soon, because it is the doorway to the most tempting and most dangerous idea in this entire story. But for now, sit with the plain shape of the mystery, stripped of any mysticism. When left alone, the world is a smoothly spreading cloud of possibilities. When something interacts with it in a way that records what happened, the cloud becomes a single fact, and no one, in 100 years, has been able to say exactly what that recording is, or where along the chain it takes hold, or why the universe should behave as though it quietly checks whether a question is being asked before it decides how to answer. It is easy to underestimate how serious this gap is, so let me say plainly what it is not. It is not a case of physicists knowing the answer and simply arguing over the words. It is not a small technical wrinkle that a cleverer calculation will iron out next year. It is a hole at the very center of our single most successful theory, a theory that predicts everything it is asked to predict, with flawless precision, and yet cannot tell you what it is describing in the one moment that matters most, the moment a world of possibilities becomes a world of fact. Every other part of the machine runs perfectly. This one gear has no teeth, and the machine turns anyway, and no one can explain how. 100 years of the sharpest minds in science have stared into that gap, and rather than filling it, they have spent the century arguing about its shape. Physicists could not even agree on whether there was anything real to explain here, or whether the whole thing was a trick of language. And so, instead of converging on a single answer, the greatest minds in the field did something remarkable. They scattered. Part 4. 100 Years and No Agreement. For 100 years, the greatest physicists alive have tried to close the gap between the smooth cloud and the single fact. And instead of drawing closer to one another over time, the way you might expect careful people to do, when they stare at the same evidence for decades, they drifted further apart. They did not just disagree about the answer, they came to disagree about whether there was even a question. Let me walk you through the three great camps, because the shape of their disagreement tells you something important, and it is not the thing most people assume. The first camp gathered around the Danish physicist Niels Bohr, and around the city where he worked, so that their view came to be called the Copenhagen interpretation. Their answer, roughly, was that the question is forbidden. Before a measurement is made, they insisted, the electron simply does not have a definite position at all. It is not that the position is hidden from us, or that we are too clumsy to see it. There is no fact of the matter. And to ask what is really happening underneath, in between measurements, is to ask a meaningless question, like asking what is north of the North Pole. On this view, the wave function is not a thing floating out in the world. It is a tool for calculating the odds of what you will see when you look. And when you look, you simply update it. Stop asking what lies beneath. There is no beneath. The second camp could hardly have taken a more opposite position. It grew from the work of a young physicist named Hugh Everett, who proposed his idea in the late 1950s, around 1957. Everett looked at the same mathematics and asked a daring question. What if the wave function never collapses at all? What if that smooth, spreading cloud of possibilities is the whole and complete truth, and it never, ever picks just one outcome? At first that sounds absurd, because we plainly do see single outcomes. The electron lands in one spot. The cat is either alive or dead. But Everett's answer was breathtaking in its nerve. Every possibility, he said, genuinely happens. When the measurement occurs, the world does not choose, it divides. One version of reality, containing one version of you, sees the electron land here. Another version, containing another version of you, sees it land there. Both are equally real. Neither is the true one. The cloud never collapses, because every branch of it simply continues, forever, side by side. This is the ancestor of what most people now call the many worlds idea. The third camp took a different road again. They proposed that collapse is a real, physical event, something that actually happens out in the world, striking at random, all on its own, with no observer required to trigger it. For a single lonely particle, this collapse is so rare as to be almost impossible. The particle can drift in its haze of possibility for an enormous time. But for anything large, anything made of a vast number of particles, the collapse becomes near instantaneous, so that a cat, or a chair, or a person snaps into a single definite state almost the moment it forms. On this view, the smooth mathematics of the wave function is not quite complete. There is a tiny extra ingredient, a real tendency to collapse, that the standard equations leave out. There is a famous image that captures how strange all of this is, and it belongs to the third camp's founder, though everyone has heard of it now. Imagine a cat sealed in a box with a device that, depending on the outcome of a single quantum event, will either release a poison or not. Before you open the box, the quantum event is in its haze of possibility, both having happened and not having happened. And if the device and the cat are governed by the same quantum rules as everything else, then the strict mathematics seems to say the cat, too, is in a blend, both alive and dead at once, until the box is opened. The man who dreamed up this scenario did not offer it as a wonder. He offered it as a reduction to absurdity, a way of saying, look how ridiculous the theory becomes if you take its smooth, never-collapsing evolution literally all the way up to the scale of a living animal. The three camps each answer the cat differently. Copenhagen says, stop asking what the cat is doing before you look. The Many Worlds camp says the cat is genuinely both, in two branches that both continue, one with a living cat and one with a dead one. The Collapse camp says the cat is never really in between at all, because a system that large collapses almost instantly to one state on its own. Same cat, same box, three utterly different accounts of what is inside before you lift the lid. So there are your three great answers, and I want you to notice two things about them. The first is how deeply they disagree. They do not merely offer different pictures of the same events. They disagree about the most basic questions you could ask. Is there a hidden reality beneath the wave function, or is the question meaningless? Does the world ever actually choose an outcome, or do all outcomes happen? Is the wave function a real physical object, or just a ledger of our expectations? Three of the finest scientific traditions of the 20th century looked at the same flawless equations and the same flawless experiments, and they came away holding views that cannot all be true at once. They cannot even agree on whether there is anything here that needs explaining. But the second thing you should notice is far more important for our journey tonight, and it is the thing almost everyone misses. Look closely at all three of these answers, and ask a simple question of each. Does this interpretation require a conscious observer, a mind, an aware watcher, to make it work? And the answer, in every single case, is no. Copenhagen needs a measurement, but a measurement in its cold, mechanical sense. It needs an interaction, not a witness. A sealed machine in a dark box does the job. Everett's Many Worlds needs no collapse at all, and therefore needs no one to cause it. The branches divide whether or not any creature is there to ride along one of them, and the collapse theories act out in the empty dark, striking at random in the depths of space, with no eye anywhere, for billions of light years. By every serious, worked-out account of quantum mechanics, watching, in the human sense, is simply not part of the machinery. This is a crucial point, and I want to plant it firmly before we go any further, because we are about to walk toward a very tempting idea that says the exact opposite, and you will need this fact as an anchor. The mainstream of physics does not, and never did, require a conscious mind to make reality definite. The popular notion that scientists proved you create the world by looking at it is a distortion, a game of telephone played across a century, in which a cold technical word, observation, got swapped out for a warm human one, awareness. The physics itself is stranger and quieter and less flattering to us than that. It says only that when the world interacts with itself in a way that records what happened, the fog resolves. It does not say the world was waiting for you. There is no line in any equation that reads, and here the human notices, and only then does reality choose. What the mathematics actually contains is far humbler and far colder. It contains interactions. It contains records. It contains the spreading of a wave and the leaking of information into a surrounding world that neither knows nor cares what it has recorded. The warmth we feel when we hear that observation shapes reality, the little thrill of importance, the sense that the cosmos has been quietly attending to us, is something we bring to the physics, not something we find inside it. And I think it is worth being honest that this cold version is, in its way, more profound than the flattering one, because it means the strangeness of the quantum world is not a strangeness about us at all. It is a strangeness about reality itself, one that would be every bit as true and every bit as baffling in a universe that never produced a single mind to be puzzled by it. And yet, even having said all that, the deep mystery does not go away. Strip out every mention of consciousness. Grant that a molecule of air can do the job, as well as a Nobel laureate. You are still left staring at the same astonishing fact. Out of a shimmering field of possibilities, reality keeps selecting a single, definite state. It does this again and again, trillions of times every second, in every corner of the universe, and no interpretation can fully explain why it happens, or where, or how the many becomes the one. The machinery does not need anyone to watch it, but the machinery still does something that no one can fully explain. So if being watched truly is not required, why does reality still seem, at every instant and everywhere, to keep on choosing? We have walked past one door without opening it. It is the door most people quietly wonder about. It is time to open it. Part 5. The Door-Marked Mind. We ended in a strange place, and I want to name it clearly before we step through the door. Reality keeps choosing, over and over, and none of the standard machinery seems to need anyone at all to watch it choose. That really should be the end of the story. But there is one link in that long von Neumann chain that we walked straight past, and it is the link that a small number of the 20th century's sharpest minds could not stop staring at. To see why they were tempted, follow the chain one more time, more slowly, and watch what happens. We place a detector at the slits, and we say a measurement has occurred. But the detector, as we saw, is just atoms, and by the theory's own logic, it should not collapse anything. It should join the electron in its haze and become a slightly larger haze. So now the detector itself exists in a blur of this happened and that happened. Very well, we look at the detector's readout. But our eye is also made of atoms, so it too joins the blur. The signal travels up the optic nerve, atoms again, into the brain, atoms again. At every stage, the fog only grows, swallowing each new system into the cloud, rather than resolving it. Following this chain honestly, the whole world, all the way up to and including your own brain, should be one enormous, ever-expanding superposition of every possible outcome, and yet that is not what you experience, not ever. This is the strange gap that von Neumann himself noticed. The chain has exactly one link that never seems to fall into the fog, your own awareness. Whatever else is uncertain, you never ever experience yourself as smeared across two outcomes. You never feel half alive to the fact that the electron went left, and half alive to the fact that it went right. You always, without exception, find a single, definite reality waiting for you when you look. The blur may run all the way up the chain in the mathematics, but it stops, somehow, at the threshold of experience. And so a small number of brilliant physicists took the boldest step imaginable. If the chain has to stop somewhere, they reasoned, and if the last link, the one place the fog never reaches, is awareness itself, then perhaps awareness is where it stops. Perhaps the act of a conscious being, perceiving the result, is the very thing that finally forces the universe to pick. Let me put that as starkly as it deserves, because it is a genuinely staggering claim. On this view, consciousness is not a spectator of the physical world. Consciousness is its author. Until a mind perceives an outcome, the universe stays unfinished, hovering in its cloud of maybe. And the entrance of awareness is the pen stroke that turns possibility into fact. The physicist most associated with this idea framed it as a puzzle, a thought experiment, and it is worth walking through slowly, because it captures the temptation perfectly. Imagine a colleague, a fellow scientist, sealed inside a laboratory, performing one of these measurements. To that colleague, inside the room, the outcome is settled the instant they see it. They look at the detector, they read the result, and for them, reality has chosen. But now imagine yourself standing outside the sealed door, waiting. From your point of view, according to the strict mathematics, the entire laboratory, your colleague very much included, is one gigantic quantum system, still hovering between possibilities, still an unresolved blur, right up until the moment you open the door and ask what they saw. Two people, two completely irreconcilable accounts of when reality became real. For the colleague inside, it became real the moment they looked. For you outside, it was still a haze until you opened the door. Both of them are following the mathematics correctly. So which one is right? When did the world actually choose? Notice how neatly this puzzle traps you, because there is no obvious escape that does not cost you something. You could say the colleague is right, that reality became definite the moment they looked, and that you, outside the door, were simply ignorant of a fact that was already settled. That feels sensible, but it quietly hands the colleague's awareness a special power, the power to finish reality, and if you grant that power to your colleague, you have to grant it to every conscious being, and suddenly minds are doing something out in the physical world that no equation describes. Or you could say that you outside the door are right, that the whole lab really was an unresolved blur until you opened it, which means your colleague, a living, thinking person, was themselves suspended in a haze of maybe, having both seen one result and seen the other, until your looking settled it. That is a deeply strange thing to say about another human being, who will insist, quite reasonably, that they experienced a single, definite outcome the entire time. Every path out of the puzzle either grants awareness a power physics never granted it, or asks you to believe that a conscious person can hang in an unresolved fog of contradictory experiences until someone else checks. There is no comfortable answer, and that discomfort is exactly why the idea was so seductive, and exactly why some very serious people were willing, for a time, to pay its price. The physicist who posed this puzzle argued that the only way to break the tie, the only way to say that reality had truly become definite at some particular moment, was to grant awareness a power that nothing else in all of physics possesses, the power to reach into the equations and force a single outcome into being. Whoever is conscious, whoever is genuinely aware, collapses the cloud. That is what makes the colleagues look decisive in a way that the detector's click was not. For a brief and heady moment, in the middle of the 20th century, this was a live idea among serious people. And I want to be fair to it, more than fair, because it is the most seductive idea in this entire story, and its failure, which we will come to, is exactly where the whole subject earns its credibility. Think about how neatly it seems to fit. The chain has to stop somewhere. The one link that never blurs is awareness. What could be more natural than to say that awareness is the stopping point, the place where possibility crystallizes into the one world we all seem to share? It even seems to explain that eerie fact about the double slit, the way the pattern dies the moment information is available. Maybe, on this reading, information is only truly information when some mind possesses it. And here, the moment you make awareness the hinge of reality, you have to slow down, because this is where wonder and rigor pull hardest against each other, and where an honest guide has to be most careful. Because the instant you say that consciousness is what forces the universe to choose, you run straight into a problem that no laboratory has ever cracked. We do not know what consciousness is. We can say a great deal about the brain. We can watch which regions light up when you see the color red. We can trace the electrical storms that accompany a decision. We can, in some experiments, even predict a simple choice, a moment or two before a person feels they have made it. But every one of those achievements describes the machinery of the mind, the processing, the reactions, the behavior. Not one of them touches the deeper riddle, which is why any of that processing should be felt from the inside at all, why there is something it is like to taste salt, or to see that particular red, rather than mere data moving silently through circuitry in the dark. The philosopher who gave this riddle its modern name called it the hard problem of consciousness, and he drew a sharp line between the questions we know how to attack and the one we do not even know how to begin. We can, in principle, explain everything the brain does. We cannot yet explain why doing any of it should feel like anything whatsoever. And so the consciousness causes collapse proposal was asking us to do something rather astonishing. It was asking us to build the entire foundation of physical reality on the one thing in all of nature that science understands the very least. It was asking the deepest, most confirmed, most precise science we have to lean its whole weight on a mystery we cannot even define. That is a great deal to ask. And within a single generation, the proposal quietly collapsed, not from a single killing experiment, but from its own accumulating weight. To understand why it fell, and why its fall matters so much for where we are going, we have to look closely at exactly what went wrong. Part 6. Why that door closed. The criticisms of the consciousness causes collapse idea came fast, and they were hard to answer. I want to lay them out carefully and fairly, because how this idea fell tells you a great deal about how good science actually polices itself, and because the pieces that survive its fall are what carry us onward. There were 3 main blows, and each one landed harder than the last. The first blow is that the idea flirts with a peculiar and lonely kind of madness. If only my awareness collapses reality into definiteness, then how do I know that yours does too? When I look at you, you are part of the physical world outside my mind, and so, by the logic of the proposal, you should be part of the haze until my awareness resolves you. But that would make you a kind of puppet, a figure who only becomes definite when I attend to you. Taken to its end, the view slides toward what philosophers call solipsism, the notion that only one mind, my own, truly exists, and that everything else, including every other person, is a shadow that firms up only under my gaze. Almost no one is willing to accept that conclusion. It is not just unpleasant, it is very close to unlivable. And a theory that leads you there has given you a strong reason to suspect you took a wrong turn somewhere far back. The second blow is that the idea is extraordinarily difficult to test, and may be impossible to test at all. Science lives or dies by the question, what experiment could tell the difference? So ask it here. What experiment could ever distinguish a universe in which consciousness collapses the wave function from a universe in which it does not? In which the collapse, or the appearance of collapse, is caused by ordinary physical interactions with no mind involved. Every prediction comes out the same either way. The detector clicks, the pattern dies. You see one outcome. There is no measurement you could set up, no needle you could watch, whose reading would swing one way if minds were doing the collapsing, and the other way if they were not. And an idea that can never, even in principle, be tested, has drifted out of the territory of physics and into something else. The third blow is the most damning of all, and it is beautifully simple. Consciousness appears nowhere in the equations. Nowhere. Not once. You can calculate every quantum prediction that has ever been confirmed to that staggering 12-decimal precision without ever writing down a single symbol that stands for a mind. The equations do not contain a term for awareness, or for attention, or for a knowing subject. They run perfectly well in a universe with no one in it. And so, to insert consciousness into the foundations of the theory, you would have to add something by hand that the mathematics never asked for and does not need. That does not look like physics. It looks like a wish. It looks like taking the one thing we cherish most about ourselves, our inner light, and painting it onto the cosmos because we would like it to be there. And here is the detail that ought to settle any lingering romance about this idea. Even the man most identified with it abandoned it. In his later years, The physicist who had proposed that awareness collapses the wave function came to regard his own idea as untenable. He judged that it edged too close to that solipsistic trap, and he was moved, in part, by new work that was beginning to show how the environment alone, with no observer of any kind, could wash the quantum fog away all by itself. The champion of the idea walked away from it. Today, the view that consciousness causes the collapse is largely discarded by working physicists, and its afterlife has been mostly in mysticism and self-help, in the culture of "you create your own reality," rather than in the pages of physics journals. As one physicist put it, with considerable bite, are we really to believe that the entire universe hung suspended, unable to become real, patiently waiting through billions of years, until at last some system sufficiently qualified to observe it, perhaps one holding an advanced degree, finally arrived on the scene? Put that way, the idea collapses under the sheer weight of its own arrogance. And yet the deeper question that the proposal raised refuses to die, because science has never actually stopped trying to catch consciousness in the act. The failed idea pointed at something real, even if it grabbed the wrong end of it. It pointed at the fact that we do not understand awareness, and that our not understanding it sits uncomfortably close to the heart of the measurement mystery. So let me show you where that unresolved question stands today, in real, current science, because it is more humbling than you might expect. Two great research programs now dominate the study of consciousness, and they could hardly be more different from one another. One of them holds that awareness arises when the brain broadcasts information widely. On this view, a signal becomes conscious when it crosses some threshold and is suddenly flung across a global network in the brain, made available all at once to many different systems, rather than staying locked in one quiet corner. Consciousness, in this picture, is a kind of publication, a moment when information goes from private to broadcast. The other program proposes almost the opposite emphasis. It says that consciousness is a measure of how tightly information in a system is woven together, how deeply and irreducibly integrated it is, captured by a single quantity that its architects simply call phi. More integration, more experience. A system with no integration, no matter how clever or how fast, feels nothing at all. These two pictures point in genuinely different directions, and for years they accumulated evidence side by side without ever being forced to fight it out directly. Then, recently, their leading proponents did something rare and admirable in science. They agreed, in advance, to a duel. In a large, carefully pre-registered collaboration, the sharpest predictions of the two theories were pitted directly against each other, with the outcomes that would count as a win locked in before any data came back, so that no one could quietly move the goalposts afterward. Hundreds of volunteers had their brains scanned while these predictions were tested, and when the results were published, around 2025, they did not crown a winner. They favored some of the first theory's claims about where in the brain conscious content seems to live, while undercutting the second theory's insistence that the front of the brain must be centrally involved. And they left both theories standing, wounded and unconfirmed. Think about what that means. Our two best scientific accounts of consciousness cannot yet agree on where, inside your own skull, the experience of being you is actually happening. We split the atom. We photograph the shadow of a black hole. We can predict the behavior of matter to 12 decimal places, and we still cannot say, with confidence, what it is that is reading this sentence, or where inside you it lives. Let that sink in slowly, without any drama, because it is easy to say and hard to actually absorb. You are, right now, having an experience. There is a warmth to the room, or a coolness. There is the quality of these words as they arrive, the particular texture of your own tiredness, the private, interior fact of what it is like to be you at this moment. That inner quality is the most certain thing you possess. It is, in fact, the only thing you have ever had direct, unmediated contact with. Everything else, every star, and atom and equation, you know only through it. And yet it is the one thing our science cannot locate, cannot measure, and cannot explain. We can map the brain in extraordinary detail. We can say which clusters of neurons fire when you feel afraid, and which light up when you recognize a friend's face. And we can even, in careful experiments, watch the machinery of a decision assemble itself a moment before you feel yourself decide. But all of that describes what the brain does. None of it explains why any of that doing should be accompanied by an inner light, why there should be someone home to feel it, rather than all those neurons simply firing away in the silent, experienceless dark, the way a calculator computes without ever suffering its arithmetic. That gap between the machinery and the felt experience of it is the single deepest hole in all of human knowledge, and we are about to walk right up to its edge. Hold that uncertainty in your hands, because we are about to test the failed idea against something far larger than a laboratory. We are about to test it against the entire history of the universe. Part 7. 13 billion years, and no one watching. We left the last part with a beautiful and vertiginous possibility hanging in the air, one that the failure of the consciousness idea does not so much refute as leave quietly standing in the shadows. The possibility is this: what if awareness is not the last thing the universe produces, the final flicker at the top of a long ladder of complexity, but the first thing it presupposes, the ground on which everything else appears? It is a beautiful idea, and there is exactly one fact that seems to break it apart completely. The universe is old, almost unthinkably old, and for very nearly all of that time, there was no one here at all. So let us do the one thing that turns philosophy into something you can feel in your stomach. Let us rewind. Not by centuries, not by millions of years, but all the way to the very beginning, and then let us watch it unfold forward again, and count, at every step, how many eyes were open to see it happen. In the beginning, there is no sky, because there are no stars to make a sky. The universe is a hot, dense expanse, and it is far too hot for atoms even to exist. Matter is torn into a glowing plasma of bare atomic nuclei and free electrons, and in that state something strange is true. Light itself cannot travel. It ricochets endlessly off the swarm of charged particles, trapped, unable to cross even the smallest distance before being scattered again. The infant universe is luminous and blind at the very same time. It is radiant, filled with light, and yet utterly opaque, and there is no one anywhere to notice either fact. Then it cools, and after roughly 380,000 years, a threshold is crossed. The electrons slow down enough to be captured by the nuclei, and the first neutral atoms form. In that instant, the fog lifts. Light, for the first time in the entire history of everything, is suddenly free to fly across space. And that ancient light is still traveling now. We can detect it. It reaches us from every direction in the sky at once. A faint hum of radiation, the oldest thing any instrument has ever recorded. It is, in a real sense, a photograph of the universe as an infant, taken long before there was anything in it that you could call a thing, and certainly long before there was anyone to hold the camera. And then, darkness. Real darkness. The atoms drift, cooling, formless. Astronomers call this long stretch the cosmic dark ages, and it earns the name. There are no stars. There are no galaxies. There is no light being made anywhere in all of creation. There is only hydrogen and helium, thinning and spreading in the black, for tens of millions of years, gathering with agonizing slowness under the faint pull of their own gravity. Picture that if you can. An entire universe, vast beyond comprehension, sitting in total darkness for tens of millions of years, with not a single source of light and not a single pair of eyes, slowly, slowly drawing itself together. Let me set you down inside that darkness for a moment, because it is one of the loneliest places you will ever visit. and it matters for what comes next. You are standing, if you can imagine standing, somewhere in the cosmic dark ages. There is no ground beneath you and no sky above, only thin, cold gas drifting in every direction, hydrogen and helium, so faint you could pass a hand through it and feel nothing. There is no light anywhere, not a star, not a spark, not the faintest glow at the most distant edge of what you could see, because there is nothing yet that shines. The darkness is not the darkness of a closed room, which still remembers the light beyond the door. It is a darkness that has never once been broken, and it lasts, not for a night, not for a year, but for tens of millions of years, while gravity does its slow and patient work, drawing the thin gas together, a little denser here, a little denser there, gathering, over spans of time that make a human life vanish to nothing. And then, somewhere in all that black, in one small knot of gas that has grown just dense enough and just hot enough at its core, something happens that has never happened before in the history of everything. A light comes on, the first star ignites, and for the first time since the fog lifted, the universe is making light again. And here is the part I want you to feel in your chest. No one is there to see it. There is no eye anywhere in all of creation. The single most beautiful event the cosmos has yet performed happens with the house lights up and every seat in the theater empty, until, at last, the first fire. Somewhere in that dark, a knot of gas grows dense enough and hot enough at its core to ignite. The first star switches on, then another, then thousands, then millions. Astronomers call this moment cosmic dawn, the moment the universe finally lights its own lamps. And these first stars are monsters, brilliant and short-lived, and in their cores they perform the alchemy that makes everything that follows possible. They forge the first heavy elements, the carbon and oxygen and iron, out of the primordial hydrogen and helium. And when they die, often in tremendous explosions, they scatter that enrichment out across space, seeding the gas from which the next generation of stars, and eventually worlds, will form. I want you to hold on to one fact from this, because we will need it soon, and it is one of the most intimate facts in all of science. Every atom in your body heavier than helium, the carbon in your cells, the oxygen you breathe, the iron in your blood, was cooked inside a star that lived and died before the Earth existed. You are made of the ash of dead stars. Here the story takes a turn that even the experts did not expect. When we finally built telescopes, powerful enough to look back into that first billion years, we assumed we would find faint, small, fumbling beginnings, little smudges of the first structures struggling to form. Instead, we found monsters. Galaxies have been found from very early in cosmic history, only a few 100 million years after the beginning, that are far brighter and far more massive than our theories predicted they could possibly be. They should not have had time to grow so large. The cosmos, it turns out, was assembling grand and orderly structures long before anyone was around to admire them, and it was building them faster than we thought the laws of physics would allow. The universe grinds on this way for a very long time. Galaxies spin up, stars are born and die in vast, silent cycles. 9 billion years pass like this. 9 billion years before a modest yellow star flickers to life in the quiet suburbs of one ordinary galaxy, wrapped in a disk of leftover debris that slowly clumps into worlds. One of those worlds is ours. It forms about 4.5 billion years ago, and it is still not alive. The very first faint stirrings of life, single cells in a warm and lightless sea, appear only around 3.5 to 4 billion years ago, and anything you could reasonably call a mind, anything capable of noticing, of asking a question, of wondering whether the universe is real, arrives only in the final, razor-thin sliver of the whole story. If you compress the entire history of the universe into a single calendar year, with the beginning on the 1st of January, then everything we would call an observer, every creature that has ever looked up and wondered, shows up only in the last few hours of the last day of December. Now hold that timeline in your hand and lay the mystery of the last few parts across it. If reality only becomes definite when it is measured, and if, as some were tempted to believe, that measurement requires an aware mind, then for nearly 13 billion years there was no one to do it. No eye opened, no question was asked. And yet stars burned, elements were forged, galaxies turned. The cosmic microwave background was released, whole worlds cooled and hardened. And here is the loop that closes around your throat. The specific atoms that would one day become your brain, the carbon and oxygen that would one day let you read this sentence and understand it, were assembled inside stars billions of years before a single brain existed to be assembled from them. So how can the process that built the observer have waited on the observer to make it real? How can the maker have been waiting on the made? The idea seems to devour itself. Let that particular fact settle all the way in, because it is more intimate than any abstraction about wave functions. The iron in your blood was forged in the heart of a dying star. The oxygen carrying through your lungs right now, the carbon holding your cells together, the calcium in your bones, all of it was cooked in stellar furnaces and scattered across space by explosions that happened before the Earth was even a cloud of dust. You are, quite literally, made of the ash of dead stars, assembled over billions of years by a universe that had no idea it was building anything, least of all a thing that could one day turn around and ask whether any of it had been real. And that is precisely the knot that tightens around the naive version of the observer idea. For the observer to have been necessary, the universe would have had to spend 13 billion unwatched years manufacturing, atom by atom, in the dark, the very thing it was supposedly waiting on to make those years real. The eye it needed to see with had to be built first, out of unseen material, across an unseen history. The dependency runs backward. The witness is late to its own creation by almost the entire age of the cosmos. It cannot be that the entire cosmos hung suspended in a fog of maybe, patiently unrealized, holding its breath through billions of years of apparent history, only to snap into definiteness in the instant that some warm, wet creature finally blinked awake and looked up. That is not a universe. That is a stage set, waiting in the dark for its audience to arrive. And nothing in physics, nothing at all, suggests that reality is so needy, so dependent on us, so much like a play, that only becomes real when someone finally buys a ticket. The naive reading, the flattering one, the one that puts our looking at the center of everything, breaks on this timeline like a wave on a rock. So how do physicists escape the trap? There are several ways out, and they lead to very different places, and it is worth laying them side by side, calmly, one at a time. Part 8. The 5 Ways Out. There are, roughly, 5 doors out of the trap we just built, and I want to walk you through each of them slowly, because none of them is silly, and each one leads to a different picture of what kind of universe you are living in. This is one of those moments where I would ask you to resist the urge to pick a winner too quickly. Just hold each one up to the light and turn it over. The first way out is the plainest, and for most physicists, it is simply the correct one. Nobody needed to watch. The entire paradox rests on a smuggled assumption, the assumption that a conscious observer had to be present for things to become definite. And we have already seen that mainstream physics never required any such thing. Strip that assumption away, remember that a measurement, in the technical sense, is just an interaction that leaves a record, and the whole problem evaporates. The universe was under no obligation whatsoever to be witnessed. Stars did not need an audience to burn. The trap was one we built for ourselves by quietly slipping the word awareness into a place where the physics only ever asked for a bump between particles. Pull the assumption, and there is no trap at all. This is the exit sign that most working physicists walk toward without a second thought. and it is important to say clearly that they may simply be right. The second way out is subtler and rather beautiful. Perhaps the cosmos was measuring itself the entire time. Remember what a measurement really is. It is any interaction in which one piece of the world becomes entangled with another in a way that records what happened. And by that definition, the early universe was nothing but measurement. Every collision of two particles, every photon absorbed by a speck of dust, every time one piece of matter touched another and came away changed, a measurement, in the physicist's bloodless sense, had taken place. The young universe was a churning ocean of such interactions, ceaseless, everywhere, at unimaginable density. On this view, reality never needed a spectator, because it was drowning in measurement from its very first instant. The world was resolving itself, moment by moment, everywhere at once, without a single mind anywhere inside it. Definiteness was not something that waited for us. It was something the universe was doing to itself, constantly, from the start. The third way out bites the bullet in the opposite direction, and it is stranger. What if reality did remain genuinely undecided, a vast, unbroken web of possibility, and it only appears sharp and singular from the inside, to creatures who happen to be embedded within it? On this reading, definiteness is not a property that the universe actually possesses. It is a perspective. It is how the whole shimmering cloud looks when you are a small part of it, riding along one thread. This is the many worlds picture, worn as a philosophy. The universe never collapses, never chooses, never picks. It contains all outcomes forever. And what you experience as a single, definite world is simply your own narrow view from inside one branch of an endlessly branching whole. On this view, nothing ever became definite in any absolute sense, and the question of who measured the cosmos dissolves, because nothing was ever measured into singleness at all. The fourth way out is older and stranger still, and it circles back, uncomfortably, toward the very idea we thought we had abandoned. What if the universe is, in some sense, its own witness? Consider that the universe is, by definition, everything there is. There is nothing outside it, and a system that contains absolutely everything, with nothing beyond its own edge, is in a curious position. It is the only thing that could ever observe it, because there is nothing else. It is a closed loop, a totality with no outside, and therefore, perhaps, its own and only observer, forever watching itself unfold from within. This is not quite the same as a mind-causing collapse. It is something more abstract and more dizzying. The idea that the universe, taken as a whole, might be the kind of self-contained thing that provides its own observation simply by being complete. Every measurement we have ever discussed involved one part of the world taking note of another part. But when you zoom all the way out to the whole, there are no longer two parts. There is just the one thing, everything, with nothing beyond it to serve as an outside observer, and also nothing beyond it that would need to. On this view, the universe is not an object sitting in front of a witness. It is the witness and the witnessed at once, a single closed system that observes itself through its own endless internal interactions, the way a vast web might be said to hold itself taut through the tension of its own threads. It is a strange and slippery idea, and it may be more poetry than physics, but it points at something the other doors do not quite reach, which is the possibility that observation was never a thing that happened to the universe from outside, but something the universe has been doing to itself all along, simply by existing as a whole with no edge. And then there is the fifth door, the oldest answer of all, the one whispered long before any of these words carried any scientific meaning. It is the possibility that there was, in fact, an observer present at the beginning, not a creature, not an eye or a brain, not something that was born and will die, but an awareness that needed none of those things, that did not wait for the first star because it was already there when the first star lit, that was watching before there was anything to watch. I want to be scrupulously careful here, because this is the door that the rest of our journey walks toward, and it is the one most easily abused. This possibility is not required by the mathematics. The equations run perfectly well without it. It cannot be tested, and it cannot be proven, and anyone who tells you that physics has established it is misleading you. But notice, and this is the crucial thing, notice that the timeline we just walked has not ruled it out either. The 13 billion year problem is fatal to the idea that a human-style mind was needed. It is not fatal to the idea of an observer that never needed to be born. I want to be honest about how these doors feel, because they are not equal in the eyes of most physicists, and I would be doing you a disservice to pretend otherwise. The first two doors, nobody needed to watch, and the cosmos measured itself, are the ones the overwhelming majority of working scientists would walk through without hesitation, and they cost you almost nothing. They ask you to give up only a flattering assumption, the assumption that our looking was ever central to anything. The third door, that reality stayed undecided and only looks definite from inside, is respectable but strange, and asks you to accept a universe endlessly branching into uncountable versions of itself. The fourth and fifth doors are the ones that lead somewhere science cannot follow, and they must be marked clearly as such. Nothing forces you through them, but nothing in the timeline slams them shut either, and that is the subtle and important point. The 13 billion year problem is a wrecking ball aimed at exactly one idea, the idea that a human-style, brain-based, born and dying mind was required for the universe to become real. It flattens that idea completely. It leaves the planar exits standing, and it leaves untouched the far older and stranger notion of an observer that never needed a brain or a birth at all. You do not have to believe in that observer, but you cannot use the age of the universe to rule it out, and it is worth being precise about why, so that no one can tell you the science has settled a question, it has merely reframed. So there are your 5 doors. Nobody needed to watch. The cosmos measured itself. Reality stayed undecided and only looks definite from inside. The universe is its own closed witness. Or there was an observer present from the first instant who needed no eye at all. And here is where all 5 roads meet, and where this part of the journey has to leave you, holding the question rather than an answer. For 13 billion years, the universe existed. It burned. It turned. It built. Whether or not anyone was there to know it. Or did it? That little question mark, hung at the end, is the whole of it. Can existence exist without being known? 4 of our 5 doors say yes, in one way or another. One of them says something far older and far stranger. And to understand why that oldest answer will not simply go away, why serious, careful people keep circling back to it, we have to leave the laboratory entirely and go somewhere physics cannot follow. We have to look at what human beings decided about this question long before there was any physics at all. Part 9. The answer we already had. Here is one of the strangest patterns in the whole history of human thought. Civilizations separated by oceans, by languages, by thousands of years. People who never traded a single word or a single map with one another kept arriving, when they turned to the deepest question they could ask, at remarkably similar intuitions. Not identical beliefs, not the same gods. Their stories differed wildly in almost every detail, and I do not want to flatten those differences, because they are real and they matter. But underneath the differences runs the same quiet possibility, again and again. The possibility that reality is never truly alone, that behind every changing, fleeting, perishable thing, there exists an awareness that does not change, that the world is, and always has been, held in the gaze of something that was watching before we arrived, and will be watching long after we are gone. But before we take a single step down these older roads, I have to be completely honest with you about where we are going, because that honesty is the entire point of a night like this. Nothing that follows is predicted by the equations. Nothing that follows can be measured, or tested, or confirmed, or disproven. We are leaving science now, deliberately and with our eyes open, and stepping into philosophy and theology, which are humanity's older, and in some ways braver, attempts to answer the very question that physics blundered into by accident. Keep that boundary clear in your mind the whole way through. What comes next is not a discovery. It is a possibility. It is what some of the most careful thinkers who ever lived proposed, long before there were laboratories, when they faced the same question we have been circling all night. Begin in the West, with a bishop and a tree. In the early 1700s, the philosopher George Berkeley proposed something that sounds, at first, like a child's riddle, and turns out to be nearly impossible to refute. To exist, he argued, is to be perceived. At first that sounds absurd, until you realize that everything you have ever known about the universe has arrived through perception. Every color you have seen, every sound you have heard, every solid surface you have ever trusted, came to you as an experience inside a mind. A thing's reality, Berkeley insisted, is not some hidden substance lurking behind that experience. Its reality simply is the experience, which raises the obvious, needling question that students have thrown at him ever since. Does the tree in the empty courtyard vanish when no one is looking at it? And Berkeley's answer was audacious, and it is the direct ancestor of everything we have been asking tonight. No, he said, the tree does not vanish, because it is never truly unperceived. There is always one observer present, an infinite mind that perceives all things, in all places, at all times, and by that ceaseless perception holds the entire world steadily in being. The reason reality does not flicker out of existence the moment you turn away, Berkeley said, is that you were never the one keeping it here. Remove every human eye from the universe, and not a single leaf would be lost, because the watching never stops. Now travel east, and start not with a doctrine, but with something you can do right now, in the dark, as you lie there. Turn your attention inward, and watch your own thoughts. A memory surfaces, and then it dissolves. An emotion rises, and then it fades. A sensation appears, sharpens, and is gone. Your mind is a river, and nothing in it holds still for even a moment. And yet, through all of it, something remains. Something notices each change without itself being changed. It was there before the thought, and it is there after the thought. Silent, continuous, unmoved. Try it, gently, right now, since you are already lying still. Let a thought come. Perhaps it is a worry about tomorrow, or the memory of a face, or simply the sound of these words. Watch it arrive. Now watch it go, replaced by the next one, and the next. And here is the quiet trick of it. Do not follow the thoughts. Instead, notice the one to whom the thoughts are appearing. Notice the noticing. There is something reading this sentence that is not itself a sentence. There is something aware of your breathing that is not itself a breath. It does not grow tired when the thoughts grow tired. It does not change color when the mood changes color. It has been there, this silent watcher, behind every moment of your entire life, behind every version of you that you have ever been, and you have almost never turned to look at it, because it is the one thing that is always looking. The philosophers of India called it the Sakshi, the witnessing self, and they made a claim about it that is either the deepest thing anyone has ever said, or a beautiful mistake, and no experiment will ever tell you which. For thousands of years, the philosophers of India pressed on a single question: what is that witness? They gave it a name, the Sakshi, the witnessing self, and they made a startling claim about it. What you truly are, they said, is not the body, and not the racing mind, and not the changing stream of thoughts and feelings that you usually take yourself to be. What you are is that silent awareness in which all of it appears. The witness is like a screen, and your entire life is the film projected upon it. The screen is never scratched by the fire that plays across it, never soaked by the flood, never harmed by anything in the story. It only ever watches. And in this tradition, that witnessing awareness is not merely personal, not just a fact about you. At its very deepest, ultimate reality itself is said to be consciousness. Not consciousness as something a brain produces, but awareness as the fundamental ground of everything that is, the single reality of which all the apparent things of the world are passing expressions. The witness inside you and the witness beneath the whole cosmos are said, in the end, to be the same witness, one awareness, never sleeping, never blinking. Turn now to the great Abrahamic faiths, and you find the same intuition again, dressed in the language of a personal God, but sharpened to a fine point. That point is called omniscience. In these traditions, God knows all things, sees all things, and, crucially, knows them continuously. Nothing anywhere is unobserved. Not a sparrow falls to the ground unseen. And this is more than a claim about knowledge. In classical theology, it becomes a claim about existence itself. Creation is not a single event in the distant past, a switch flipped once and then left to run on its own. It is held in being, at every single instant, by the ongoing attention of its creator. Withdraw that attention for even a moment, the theologians said, and everything would simply cease to be. The universe does not merely need to have been made once. It needs, right now, to be sustained, continuously known, continuously upheld by an unbroken act of divine attention. There is a subtler version of this still, sometimes called panentheism, which holds not that God is the universe, but that the universe exists within God, the way a thought exists within a mind, contained by it and known by it, and yet not identical to it. It is the same inversion we brushed against earlier, when we wondered whether matter might appear within awareness rather than the other way around, and here it is given a face. And even modern philosophy did not abandon this question. In the 20th century, the thinker Alfred North Whitehead built an entire metaphysics around the idea that reality is not made of inert stuff at all, but of events, of moments of experience, woven together, and that a God is intimately involved in every one of them, taking in each fleeting moment as it happens, so that nothing that ever occurs is truly lost. Now step back and look at these roads together, Berkeley's sustaining perceiver, the witnessing self of the Indian philosophers, and the reality that is consciousness, the all-knowing, all-sustaining God of the Abrahamic faiths, the encompassing God of panentheism, Whitehead's cosmic experience gathering up every moment, built in different centuries, in different tongues, by people who would have found one another's frameworks strange and foreign, and yet they converge, again and again, on a single shape, an awareness that does not depend on being born, that occupies no single place, that never begins and cannot end, and by whose unbroken watching there is a definite world at all. It is very, very hard to look at that convergence and feel nothing. But now I have to let the other voice into the room, because it has been waiting, and it is not easily answered. Many careful thinkers reject every one of these ideas, and their objection is sharp. The remarkable similarities across cultures, they say, may tell us far more about the human mind than about the universe. We are storytelling creatures, and above all, we are creatures whose every experience is centered on awareness. We have never known existence from any vantage point except the inside of a watching self. So when we face the dark and the unknown, we do the most natural thing in the world. We imagine someone there, not because someone is there, but because we cannot easily imagine anything else. A child alone in a dark room fills it with presences. Perhaps a species alone in a vast cosmos does exactly the same. On this view, the fact that so many traditions reached for a cosmic witness is not evidence that one exists. It is evidence of how the mind that reached is built. Similar answers need not point to a shared truth. They may only reveal a shared psychology, and a belief being ancient, or comforting, or nearly universal, has never once, by itself, made it correct. That objection has real force, and honesty demands that we sit with it, rather than hurrying past. Which leaves us needing to ask the question from a completely different direction. Not who is doing the watching, but what, exactly, is being watched. Part 10. Maybe it was never made of stuff. For 4 parts we have circled a single word, observer, and asked who or what might be doing the watching. Now let us turn the whole question inside out. Forget for a moment who is looking. Ask instead what is being looked at. What is the universe actually made of? Because it is entirely possible that we have had the answer wrong from the very beginning, and that the real answer changes everything about the mystery we have been chasing. Ask almost anyone what the world is built from, and they will say matter, stuff, tiny, solid things assembled into bigger things. It is the most natural belief in the world. Rap your knuckles on a table, and the table answers back, hard and present and undeniably there. For most of the history of science, this was bedrock. Reality was made of substance, and everything else, all the patterns and forces and laws, was just a story we told about the substance. But push down past the table, past the molecules, past the atoms, down to the smallest level we can describe, and the solid stuff quietly disappears. What you find at the very bottom is not a miniature pebble. It is the wave function, that spread of possibilities we met at the very beginning of this journey. And here is the thing that almost no one stops to notice. A wave function is not a substance. You cannot hold it, or weigh it, or point to the place where it sits. It is a ledger. It is a precise accounting of what might happen and how likely each outcome is. It is, in the most literal sense of the word, information. That realization crept up on physics slowly, and then all at once. If the most fundamental description we have of anything is a description of information, of probabilities, of possible answers, then perhaps information is not merely how we describe reality from the outside. Perhaps information is what reality is. An entire field grew up around this idea, called quantum information theory. It stopped asking what particles are made of, and started asking what they can know, and store, and transmit. The humble bit, the yes or no, the 0 or 1, the smallest possible unit of a difference, was joined by its stranger quantum cousin, the qubit, which can hold yes and no in suspension at once. And as physicists rewrote the quantum world in the language of information, they discovered something almost eerie. Nature guards its information with iron rules. Quantum information cannot be perfectly copied. It cannot be truly erased from existence. Push it into the most destructive object we know of, a black hole, and physicists now believe that even that cannot annihilate it. The universe, it seems, keeps its books with a fanatic's care. Nothing is ever fully lost. The physicist who saw where all of this was heading, decades ahead of nearly everyone, was John Archibald Wheeler, the same man who gave the black hole its name. Late in his life, he distilled the whole vision into 3 words that still ring like a bell across physics. It from bit. Wheeler never claimed to have solved the mystery. He claimed only that every attempt to understand reality seemed to lead back, again and again, to information. And his meaning was radical. Every it, he said, every particle, every field, every force, every object you have ever touched, derives its very existence, in the end, from bits, from the answers to yes or no questions posed to the world. Reality, Wheeler suggested, does not bottom out in matter at all. It bottoms out in information, in the answers that nature gives when it is asked. Strip away the substance, and what remains underneath is not smaller substance. It is a pattern, a code, a vast, self-consistent web of answers. And then physics found something that made Wheeler look less like a dreamer and more like a prophet. It began, of all places, with black holes. When physicists worked out how much information a black hole can contain, They expected the answer to scale with its volume. The bigger the box, the more you can cram inside it. That is how everything in ordinary life works. But that is not what the mathematics said. The maximum information you can pack into any region of space turns out to depend not on its volume, but on its surface area, on the size of the boundary around it, not the space within. It was as though the true storage of a chunk of the universe lived on its outer skin. That single strange fact grew into one of the boldest ideas in modern physics, the holographic principle. The suggestion is that the three-dimensional world we move through, with all its depth and distance and solidity, may be something like a projection, that everything happening inside a volume of space could be fully encoded as information on a lower dimensional boundary surrounding it. A hologram, after all, is a flat sheet that, lit correctly, throws up a full three-dimensional image. The holographic principle whispers that the universe might work the same way. That depth itself could be a kind of encoded illusion, and the real accounting is happening on a surface we cannot see. It is important to hold this loosely, and I will keep saying so, because this is exactly the kind of idea that gets oversold. The holographic principle remains a powerful theoretical framework, not an experimentally confirmed description of our universe. And the frontier goes further still, into territory that is genuinely unsettled, still being fought over in the journals, but breathtaking if it holds. A large body of recent work suggests that space-time itself, distance, geometry, the very fabric that describes gravity, may not be fundamental at all. It may be woven out of quantum entanglement, with space and time springing up from the entanglement of tiny bits of information. Tighten the entanglement between two regions, on this view, and they lie near each other. Loosen it, and they drift apart. Cut it entirely, and the space between them simply ceases to be. Pull out the entanglement, and space-time comes unstitched, like fabric losing its thread. Let that settle, and hold it loosely, because it is not yet proven. It is a frontier, not a verdict. But if it is right, then space and time are not the stage on which the universe performs. They are the performance. They are what a deeper layer of pure information looks like, when there is enough of it, entangled in the right way. Underneath the stage, there is no stage. There is only information, relating to itself. It is worth pausing to appreciate how extraordinary this shift has been. For 2,000 years, philosophers argued over whether reality was made of earth, water, fire, atoms, fields, or energy. Every answer named a substance, some ultimate stuff the world was carved from. Few of them ever imagined that the deepest answer might not be a substance at all, but a relationship. Not a thing, but a pattern. And that is exactly where the wonder turns, once more, into a question that physics cannot fully answer on its own. Because information is a strange kind of thing, if it is a thing at all. Everywhere else in our experience, information needs somewhere to live. Words need a page. Music needs a groove in a record, or a pattern in a file. A memory needs a brain. Information always seems to demand a medium, a substrate, a place where the pattern is held. So if the universe is, at bottom, information, then where is it written? What is the page beneath the page? What holds the code, when the code is everything? It is worth lingering on how genuinely peculiar that question is, because in ordinary life, we never meet information that floats free of any medium. Think of every piece of information you have ever encountered. The words on a page are ink pressed into paper. The words in a book on a screen are patterns of charge held in silicon. A song is grooves cut in vinyl, or magnetized specks on a disc, or a shape carried in the air to your ear. A memory is some pattern held, somehow, in the wet tissue of a brain. In every single case, the information rides on something. It is a pattern impressed upon a substance, and if you take the substance away, the pattern goes with it. Erase the disc, and the song is gone. Burn the page, and the words are gone. Information, in all our experience, is a guest that always needs a house. And yet here is physics, telling us, at its deepest level, that the house itself, the matter, the substance, the very stuff we thought was doing the holding, dissolves into information when you look closely enough. The guess turns out to be the foundation. The pattern is holding up the very thing we assumed was holding up the pattern. And that inverts the ordinary picture so completely that the old question, where is it written, no longer has an obvious place to land. There may be no page beneath the page. There may be only patterns, relating to patterns, all the way down. Now, many physicists would stop right here, and firmly. For them, information does not need a reader, any more than gravity needs an audience. In modern physics, information is often treated as an objective property of the world itself. A particle's spin can encode information whether or not anyone measures it. A black hole can preserve information whether or not anyone ever discovers how. On this view, information is not knowledge. It is structure. It is relationship, correlation, the bare fact that one part of the universe is lined up with another. The universe need not be understood in order to exist. It need only obey its own laws, quietly, indifferently, forever. Asking who holds the information, on this reading, is like asking who holds the number 7. No one does. It simply is. And yet that answer leaves another mystery untouched, and this is where science and philosophy begin to use the same word in two different ways. In physics, information usually means measurable physical states and correlations, something out there in the world, whether or not any mind is present. In ordinary language, information usually implies meaning to someone, a message, a signal that lands somewhere and matters to somebody. Whether those two ideas are ultimately the same thing, or only share a name by accident, remains an open philosophical question. Physics has never had to settle it, because physics has never needed the second meaning to make its predictions work. But the question does not disappear just because the equations can ignore it. Every scientific revolution has quietly removed one more layer of certainty. We lost the idea that the Earth was the center of things. We lost the idea that matter was solid. We lost the idea that space and time were absolute and unchanging. Each time, something we were sure was bedrock turned out to be a story. And now we may be circling something even deeper, the last quiet assumption almost no one thought to question. The idea that the pattern and the reading of the pattern are two entirely separate things. Hold that thought, because a very different kind of thinker is about to walk into the room and pour cold water over everything we have said tonight. And the cold water, it turns out, is some of the finest physics ever done. Part 11. The Cold Water. We have traveled a long way toward wonder, minds that might shape reality, a witness that never blinks, a universe made of information that seems, faintly, to lean toward a knower. So now, in fairness, and fairness is the whole soul of science, we have to hand the floor to the people who believe that every step of that journey took a wrong turn. And I want to be honest from the outset. They hold the strongest hand at the table. This is the part where the romance meets cold water, and the cold water is real, and it is beautiful in its own severe way. The skeptic's case begins by going right back to the word that started all of this. Observation. The entire mystery, remember, rested on the intuition that something special, something almost magical, happens at the moment a measurement is made, that the universe somehow behaves differently when it is watched. But what if there is nothing magical about it at all? What if a measurement is simply an ordinary physical process, one that we can now describe in complete, unmysterious detail? That process has a name. It is called decoherence, and for most physicists, it is the quiet demolition of the entire paradox. Here is the idea. In the pristine thought experiments, we always imagine a particle alone, drifting in its delicate haze of possibility, undisturbed. But in the real universe, nothing is ever alone. A particle is ceaselessly bombarded by stray photons, by air molecules, by the faint thermal glow radiating from every warm object nearby, by the cosmic background radiation itself. And the instant it so much as brushes against any of them, something decisive happens. It becomes entangled with them. Its fragile wave nature no longer belongs to it alone. It bleeds outward, spreading into the countless, uncontrollable degrees of freedom of the surrounding world. And once that information about the particle's path has leaked into the environment, once the world has, in effect, taken note of where the particle is, the interference pattern, that unmistakable fingerprint of quantum possibility, is washed away. Not erased by a mind, erased by the environment, automatically, blindly, in an instant. And now comes the number that ends the debate for most physicists. The bigger the object, the faster this happens. And not gradually, but catastrophically fast. A single grain of dust, floating in ordinary air, loses its quantum coherence in a fraction of a second, so small that the mind simply cannot picture it. For a measuring device, or a cat, or a human being, decoherence is effectively instantaneous, complete, before any conscious creature could even begin to notice. This is the real reason you have never seen a coffee cup in two places at once. It is the real reason you have never caught a cat suspended between life and death. It is not because someone is watching. It is because a large object cannot avoid entangling with its surroundings for even the briefest instant. The world is measuring itself, everywhere, trillions upon trillions of times every second, with no observer, no eye, and no awareness anywhere in the process. Look at what that does to the mystery. The measurement that we thought required a special, privileged observer turns out to be the single most common event in the entire universe. A blind, automatic, physical fact happening constantly, in the dark, in the deep of space, with no one there. Consider that even the faint afterglow of the Big Bang, that ancient radiation drifting through all of space, is enough, on its own, to decohere a dust grain floating in the void, to nudge it out of the quantum haze and into a definite state, with no eye, no instrument, and no mind for light years in any direction. The universe does not wait for a laboratory. It measures itself with starlight, with stray heat, with the cold background hum left over from its own birth. Everywhere, at every instant, matter is brushing against matter and leaving records in the environment. And every one of those records is, in the physicist's flat and unromantic sense, a measurement. If measurement is what makes the world definite, then the world has been drowning in it since the very first moment, and it never once needed us to supply it. And so the tempting idea from earlier in our journey, the idea that a mind is needed to make reality definite, is not merely philosophically fragile, which we already saw. It is unnecessary. There is now a purely physical account of why the quantum fog resolves into the solid world we live in, and that account contains no soul, no God, and no consciousness. It contains photons and air molecules. That is all. It is a formidable case, and any honest telling of this story has to grant that the burden of proof sits squarely on wonder, and that the skeptic carries far less weight to lift. But here, and this is where a lesser account would cheat, and where scientific honesty demands that we do not, the story is not quite over, because decoherence, for all its power, does not actually finish the job, and the physicists who understand it best are the very first to say so. Decoherence explains, beautifully, why we never see a superposition, why the world always looks classical and definite and orderly, but it does not explain why, in any single run of the experiment, you get this particular outcome rather than the other one. Think of the cat again. Decoherence takes the ghostly blend of alive and dead and separates it cleanly into two distinct, non-interfering possibilities, each of them fully formed. What it never does, on its own, is tell you which one you will actually find when you open the box. That final step, the leap from a menu of separated possibilities to the single actuality you actually experience, has a name among specialists. It is called the problem of outcomes, and it remains genuinely, stubbornly unsolved. When quantum physicists have been surveyed on whether the measurement problem is settled, no consensus emerges at all. The experts scatter across every possible answer, just as they did 100 years ago. So decoherence is a giant stride toward the exit. It is not the exit itself. There is one interpretation that responds to this remaining gap in the boldest way imaginable, by insisting that there is no gap, because nothing is ever selected. If decoherence splits the world into cleanly separated branches, a living cat branch and a dead cat branch, then why assume that the universe reaches in and deletes one of them? Perhaps both simply persist. Perhaps reality contains both outcomes, side by side, forever. And what you call you is riding along just one of those branches, entirely unaware of the others. This is the descendant of the many worlds idea we met near the beginning, and notice its great advantage here. It needs no collapse, and no chosen moment, and therefore no observer to cause anything whatsoever. It is worth pausing on how much this view asks you to swallow, because its economy at one end is paid for by extravagance at the other. To avoid the awkward business of the universe ever choosing an outcome, it proposes that the universe chooses all of them, forever, splitting at every quantum event into an unimaginable and ever-growing forest of parallel realities, each as real as this one, most of them containing some version of you who took the other branch. Every measurement, every collision, every trembling of a particle anywhere spawns the full spread of possibilities, and none is ever discarded. It is either the most honest reading of the mathematics, taking the never-collapsing wave function at its literal word, or it is the most lavish metaphysical bill ever presented, an infinity of unobservable worlds invoked to explain the one we actually see. Physicists genuinely disagree about which it is, and they disagree without heat, only because there is no experiment that could ever settle it. And yet, for our question tonight, its appeal is undeniable, because it dissolves the observer completely. Nothing collapses, so nothing needs to be made to collapse. There is no privileged moment of choosing, so there is no chooser to hunt for. Strip away that loaded word, observation. Watch the environment do the measuring. Let decoherence dissolve the fog, and let the flawless mathematics run its course, and the great paradox seems to quietly evaporate. There is no ghost in the machine. There is only the machine, vast and indifferent, endlessly recording itself, with or without anyone there to care. It may well be the correct picture. I want to say that plainly, because I have spent a long time tonight walking you toward wonder, and intellectual honesty requires me to say that the cold, observer-free account might simply be true. But notice, before we move on, what even this triumphant account has quietly left standing in the corner of the room. Decoherence told us why the world looks definite. Many worlds told us we need not agonize over which outcome is real. But neither one of them has told us why there is a definite experience at all. Why you open the box and meet one single cat. Why there is one particular world that you actually find yourself inside, rather than a bookkeeping abstraction spread across countless branches you never feel. The hardest form of the question did not get answered. It slipped through the net while we were admiring the size of the catch, and that raises a strange, deflating, and quietly liberating suspicion. A century of the most brilliant minds who ever lived has failed to resolve this. What if the reason is not that the answer is too hard to reach? What if the reason is that the question itself was built wrong from the very beginning? That we have been demanding an answer in a shape that reality was never going to provide? Sit with that, because it is not a defeat, it is a door. Part 12. The mirror that faces itself. Perhaps the observer was never the mystery. Perhaps we have been asking the wrong question all along. All this time, we have been hunting for the observer as though it were a thing, an object hidden somewhere inside reality, waiting to be found, a mind, a machine, a god, at the edge of the universe. But every candidate we caught turned out either to be unnecessary or to dissolve the moment we examined it closely. The conscious observer was not needed. The detector was just more atoms. The environment did the measuring blindly. And maybe that pattern is the clue we kept overlooking. Maybe the observer was never an object within reality at all. Maybe observation is something stranger, a condition of there being a reality in the first place. Follow that thought, and you walk straight into the oldest trap in philosophy. Suppose reality really does require an observer in order to become definite. Fine, but an observer is itself something that exists. So what makes the observer definite? Another observer, watching the first? And what makes that one real? Another still, behind it. You have started an avalanche that cannot stop. Observer behind observer behind observer. A hall of mirrors receding into infinity. Philosophers call it an infinite regress, and it is fatal to any theory that tries to explain existence by pointing to yet another existing thing. Every answer just relocates the question one step back and asks it again. If existence needs a witness, and the witness needs a witness, then nothing is ever explained, and nothing is ever grounded, and the whole tower topples into an endless downward stack. There is only one way that regress can ever end. Not with a final observer who is watched by some further observer, but with something that observes itself, something that is, at once, the seer and the seen. And here is the quietly astonishing fact. We already know of exactly one thing in all the universe that does this, you, right now. Awareness is the single phenomenon that can turn back on itself. It can be conscious of being conscious. It can hold itself as its own object, without needing anything outside it to complete the loop. Self-awareness is the one place in the entire structure where the mirror faces the mirror, and the regress finally closes. Wherever the chain of observation was going to stop, it could only ever stop there, in something that is aware of itself. Which forces a question that would have sounded absurd in almost any other century, but no longer does. You are made of atoms. Those atoms were forged inside ancient stars, scattered across space by their deaths, gathered slowly into a world, and assembled, over unthinkable stretches of time, into a creature that can look up at the very sky those stars once lit, and understand it. Think carefully about what that means, structurally, leaving all sentiment aside. You are a piece of the universe, and you are aware, which means that the universe, through you, has become aware of itself. When you look at a distant galaxy and grasp what it is, that is not a mind observing the cosmos from outside it. There is no outside. That is the cosmos opening an eye. For 13 billion years, matter arranged and rearranged itself in the dark, and then, in you and in every conscious being, it began to know that it exists. Let me hold you here, at the very edge of sleep, because this is the softest and largest place the whole journey arrives at, and it asks nothing of you but to notice. Imagine, or simply feel, that you are looking up at a single, distant point of light, a galaxy so far away that its light left it before there was an Earth to receive it. You are looking at it, but trace the looking backward. The eyes doing the looking are made of atoms that were themselves forged out there, in stars not so different from the ones you are watching, and flung across space, and gathered into a world, and slowly, over billions of years, arranged into a creature that could open those eyes and comprehend the light. So when you look at that galaxy and understand, even a little, what it is, something has closed. A loop that took the entire age of the universe to complete has quietly clicked shut. The stuff of the cosmos, after 13 billion years of drifting in the dark, has assembled itself into a shape that can turn back and behold the rest of itself, and know that it is beholding. You are not a visitor at the window of the universe. You are the universe, grown a window, and looking through it at its own vast body. And the strangest part is that you can feel this happening right now, in the quiet, without moving at all, simply by being aware that you are aware. I want you to stay in this for a moment, quietly, because it is the still center of everything we have circled tonight. You do not have to travel anywhere to find the strangest thing in the universe. You do not have to look through a telescope or into a particle collider. You only have to notice that you are noticing. Right now, in the dark, some arrangement of stardust is aware of itself and is wondering whether awareness is woven into the foundations of reality, and that wondering is itself the very thing it is wondering about. The eye is turned around, looking at the eye. The universe is not out there, being watched by you from a safe distance. The watching is happening inside it, and it is made of it, and for this brief moment, in this warm and fragile point of view, the whole thing has folded back to regard its own face, not a spectator who wandered in from somewhere else. The cosmos, briefly and locally, come awake. So perhaps we have had the picture upside down this entire time. Perhaps we are not observers who happen to appear in the universe, late and by accident. Perhaps we are the universe's own act of observation, local, temporary, fragile expressions of something that is trying, everywhere and always, to witness itself. Not separate watchers peering in at a world, but the world's own awareness, briefly concentrated into 10 billion warm points of view. And if you allow that, even as a possibility, then the most ancient idea in this entire journey stops sounding like superstition and starts sounding like a hypothesis. Because if awareness is woven into the ground of reality, if the universe is the kind of thing that can wake up, then a timeless, boundless version of that same awareness, one that does not depend on any single brain or any single moment, is no longer a category error. It is simply the question taken to its limit. What would it mean for such an observer to sit outside space and time? Not far away, but in a place where far and when have no meaning at all. What would it mean for existence itself to be, at its very root, an act of being known? We cannot answer that. Let me be completely honest, one final time. Nothing we have found tonight proves any of this. But notice how far the question has traveled from where it began. We started with a pattern of light on a screen, a few bright and dark bands behind a wall with 2 slits in it, and we are ending at the threshold of the deepest question a mind can form. So let me do the only honest thing left to do. Let me lay the 3 real possibilities side by side, refuse to choose for you, and let you stand where every thinking person who has ever faced this must finally stand, alone with the mystery. The first possibility is the simplest, and it may very well be true. Reality is entirely, exhaustively physical. Consciousness is not fundamental to anything. It is a remarkable but ordinary product of the brain, an intricate pattern of matter that switches off completely when the matter stops. The universe existed for billions of years without a single flicker of awareness, and got along perfectly well. There is no cosmic witness, no eternal observer, no deeper meaning waiting beneath the mathematics. There is only the vast machine, and we are a fleeting arrangement within it that briefly lit up, asked why, and will one day go dark. It is a stark picture. It is also by far the most economical, and economy is a virtue that science has earned the right to trust. The second possibility inverts everything. Consciousness is not produced by matter. Matter emerges within consciousness. Awareness is the fundamental fabric, and the physical world, the atoms, the stars, space, time, is something that arises inside it, the way a landscape arises inside a dream, without the dream being made of soil and stone. On this view, the universe is, at its deepest level, mental. And we are not machines that somehow generated minds, but minds that dreamed up the appearance of machinery. It sounds mystical, and yet it solves, in a single stroke, the one problem the physical picture cannot touch: why there is any experience here at all. The third possibility is the boldest and the oldest. There exists an eternal observer, not a being among other beings, not a force in the equations, not anything an experiment could ever detect or a telescope find. Not required by the mathematics, which runs perfectly well without it, and yet, perhaps, necessary for a reason the mathematics can never reach, necessary to explain not how reality behaves, but why there is any reality here for the equations to describe at all. An awareness that never began, holding existence in being simply by knowing it. The witness that closes the infinite regress, not by being watched, but by being the one thing that needs no watcher. 3 answers, 1 universe, and not a single experiment, in principle or in practice, that can ever tell them apart. This is where physics ends, and where you begin. Perhaps the greatest discovery of quantum physics was never that particles behave strangely. Perhaps it was that the universe, in the end, forced us to ask a question we were certain science had left behind long ago. What does it mean to observe? What is this awareness we carry and cannot explain? Why does reality exist in a form that can be known at all, lit from within by understanding, rather than sitting forever in the dark, unwitnessed, and unaware that it is even there? Whether the final answer turns out to be physics, or philosophy, or God, one strange truth remains, and it will still be waiting for you long after this ends. The deepest mystery in the universe may not be hidden out among the stars. It may not be buried in the equations, or lost in the first instant of time. It may be much closer than that. It may be the awareness that is reading these words right now. And so we leave you, not with an answer, but with the question that started everything, the one you are now holding entirely on your own. If reality only becomes real once it is known, then what, exactly, is doing the knowing? Thank you for wandering all the way to the edge of this question with me tonight. If this slow kind of exploration is how you like to drift off, a quiet like or subscribe genuinely helps this channel grow, and it means more to me than I can easily say. And the next time you notice that you are noticing, remember that it may be the strangest fact in the cosmos. Good night, and may you never look at the act of observation the same way again.